Here's the video key for test 3, which includes material from chapters 5 and 6. Number 1, compute -1, that quantity, to the 81st power. Well, what we know is when a -1 or any negative is raised to an even power, it is positive. When it is raised to an odd power, it is negative. So -1, that quantity, to the 81st power is equal to a -1. Number 2, write addition equation to represent the scenario, then solve the problem. The team gained 18 yards on the first play, lost 7 yards on the second play, and then gained 8 yards on the third play. What was the team's net gain or loss? This is an addition problem. So we will start with 18-yard gain would be a positive 18 plus a 7-yard loss would be plus a -7 plus. Then gained another 8 yards on the third plus 8. So it has to be an addition problem. So we have to have both of those pluses in this for the correct to have a correct answer. What was the team's net gain or loss? Well, I can group numbers. The -7 plus the 8 would give me a gain of 1, a net gain of 1. So 1 plus 18, it is 19 yard net gain. Number 3, evaluate 4 plus 2 times a -7. Now with order of operations, multiplication and division come before addition. So my next step would be to multiply the 2 times the -7, which gives me a -14. Now I can add 4 plus a -14, gives me an answer of -10. Number 4, find the additive inverse. Now the additive inverse is what you would add to a number to get a 0. So it's the opposite. For A, it would be -7. For K, it'd be -K. For C, instead of x plus 3, it's going to be negative the quantity x plus 3 or -x minus 3. And for D, it would be the opposite, or negative the quantity, -2k plus 7, which would give 2k minus 7. Number 5, evaluate 6 minus a -13 plus 5. Well, we know that minus a negative turns into a plus. So we now have 6 plus 13 plus 5, which 6 plus 13 is 29, or I'm sorry, 19 plus 5 is 20. Number 6, determine if the following statement is true, false, or sometimes true. Justify your answers. All right, well, it is sometimes true. Now, the reason it is sometimes true is that if x and y are both negative or positive, it is false. If only one of x or y is negative, then it's true. The example would be if x was a -1 and y was a -1, well, that would be a positive product. And the right side is always going to be negative because of the absolute values of the negatives out front. But if x is negative and y is positive, or x is positive and y is negative, then you'll have a negative product on the left and you'll have a negative product on the right. Number 7. Perform the indicated computation. The quantity 9 minus a negative 4 minus 12. So inside brackets, you end up with a positive 13 because that minus a negative turns into a plus. And then you'd subtract 12. So 13 minus 12 gives you a 1. Number 8. Perform the indicated operation. Express your answer in simplest form. 9/13 plus 1/7. What I know is that I have to have a common denominator. And since both 13 and 7 are prime, the common denominator is 91, or the product of 13 and 7. All right, so I'm going to have to multiply the top and bottom of the left by 7 for 7. And the top and bottom of 1/7, I'm going to have to multiply by 13, which gives me 63 over 91 plus 13 over 91, or 76 over 91. So what remains to be determined is whether or not we can simplify 76 over 91. The only factors of 91 are 1, 13, 7, and 91. And none of those go into 76 evenly. So this would be our answer in simplest form. Number 9. Perform the indicated operation. Express your answer in simplest form. Well, again, I have to have common denominator, which in this case will be the 8. 1 is equal to 8 over 8. So I will end up with 15 minus 8 over 8, or 7/8 is my answer. Number 10. A teacher bought 42 markers at the beginning of the year. At the end of the year, 6 were still working. What fraction of the package of markers was still working? Express your answer in simplest form. Well, there were 6 markers left at the end of the year, and there were 42 to begin. Both 6 and 42 have a common factor of a 6, so I will reduce that to a 1/7. So 1/7 of the markers were still working. Number 11. Lori bought 1/5 pound basil and 1/7 pound of oregano. How many pounds of herbs did Lori buy in total? Well, I would add my 1/5 pound basil to my 1/7 pound oregano. The common denominator is 5 times 7 because they're both prime, so it's 35. I will multiply the left by 7 over 7, or the left term, or 1/5, and I'll multiply 1/7 over 5 over 5. So I end up with over 35, 7 plus 5, or 12/35 of a pound of herbs. Find the product and write your answer in simplest form. You have 9/7 times 3/8. I cannot simplify this by cross canceling or any numerator with a denominator. So I end up with 27 divided by 56. And if you look at this any further, there are no common factors between 27 and 56. So 27 over 56 is the answer in simplest form. 13, find the quotient. Write your answer in simplest form. Well, I know that with division of fractions, I have to flip the denominator, or the divisor, I guess, would be the second fraction and turn it to a multiplication. So now I multiply and I get negative 65 over 18. There are no common factors between negative 65 and 18. So this is the fraction in simplest form. Now, a lot of these examples don't have anything to simplify, so I would say make sure you look on the test for answers that you would need to simplify. Number 14, divide. Write your answer in simplest form. And we start with mixed numbers. So what I need to do first is to write each mixed number as an improper fraction. So for 6 and 5/6, to get that into an improper fraction, it will be 6 times 6 plus 5 over 6. And then it will be divided by, as an improper fraction, 3 times 5, the denominator, plus 2 over 5. So to simplify the first fraction, I end up with 41 over 6 divided by the second fraction will be 17 over 5. Invert and multiply. I'm looking for any terms that I could cancel, and I don't have any. So our answer here will be 205 over 102. Now I'm going to write my answer as a mixed number because my number started as a mixed number. And so this would be equal to 2 and 1 over 102. 15. Write the fraction represented by the shaded area for each figure in the appropriate space on the right. Each fraction should be written in simplest form to receive full credit. So what I see on A in 15 is each triangle represents 1/4 and 3 of them are shaded. So A will be equal to 3 out of 4 spaces are shaded. B. In B, I look at this rectangle that is divided into 8 equal rectangles, and 3 of them are shaded. So the amount, 3 out of the 8 are shaded. Moving on to C. Well, I'm going to have to do a little counting here because I see that it is those little triangles that are the big triangles split into the smaller triangles, and it's the smaller triangles that are shaded. So counting, I'm going to count them 1, 2, 3, 4, 5, 6, 7, 8, 9 on the top row, 10, 11, 12, 13, 14, 15, 16 after the second row, 17, 18, 19, 20, 21 after the third row, 22, 23, 24, 25. So I know there are a total of 25 triangles. And when I count the shaded triangles, I get 1, 2, 3, 4, 5, 6, 7. So 7 out of the 25 are shaded. And then D. I look at the rectangle and it's divided into 20 smaller squares. 20. And when I look at the shaded area, there are a total of 8. Now, in the fraction 8 over 20, there is a common factor, and that common factor is a 4. So I can write this as 4 times 2 divided by 4 times 5. I can cancel that common factor, and my final answer is 2/5. So I'm actually going to erase my work so we get a little clearer on the key.